live. No. Oh my God. Oh my God. Okay, what are we doing? We're doing this. Apparently we're doing this because I couldn't figure it out. I can't figure it out. Oh my God. Okay, I'm gonna go this. Let's see if I lag. The reason why, because I'm tired of lagging. So, what are we doing? We're talking about abacus. And this abacus, oh, this is not right. How am I going to do this? What's going on? Oh, I know why. I know why. Hi, everybody. Hi. My name is Lynette, and you can't see me right now because okay. What are we doing? We're talking about the abacus. This is the abacus, and this abacus is, let me see if I can get rid of this. Delete. Okay, so we're talking about the abacus. We are counting 1, 2, 3, 4. Do you see that? I don't know if you can see that. Let me see if I could change that. All right, let's see if we could do that. Okay, what are we doing? We're talking about this. We are talking about counting 1, 2, 3, 4. Here is my abacus. My abacus is a counting tool that helps me add, subtract, excuse me, multiply, and divide. So here is 4, just like on a die, we have 4. 1, 2, 3, 4. What we want to do is be able to supertize, right? What is supertizing? Supertizing is this really fancy term to say, what I want to see is I want to know that this is 4. So instead of having the kids count 1, 2, 3, 4, we look at it and bam, that's what 4 is. So that's kind of cool, right? Okay, so then we have a question. Well, I know that this is 4. I know this is 4. But what happens to 5? Well, if you know, 5 is the top bead up here. This is the top bead. This top bead is 5. How do I know? Because it is touching the horizontal bar. The horizontal bar is what lets me know what is being counted. So what's being counted is this. This horizontal bar tells me what's being counted. That means that this is my beam. This beam tells me that it's being counted. So I have 5 and then 6. How do I know? Because this is 1, 2, 3, 4. So it's easy to use. Simple to use, easy to understand. So I have 5 and then I have 6 and I have 7. So I have 5, 6, 7, 8. 5, 6, 7, 8, and then 9. What we're going to do is we are going to learn how to count on the abacus first, and then we will go into adding, subtracting, multiplication, and division. Just so you know. Anybody have any questions so far? Let me know. I'm going to try to keep an eye on the chat, and didn't realize that I was actually going live. I was trying to figure out how to go live on StreamYard. But anyways, so now you might be wondering, well, what do we do with 10? Well, funny enough, just as we did this, right? Just as we write 10, we have our tens and our ones, we can do the same thing. Abacus mimics the way we write. So we have our 0 and we have our 10. How do I know that this is tens? Because if you look, this is my ones. Here is my ones. If you can see, there's a dot right there. This dot, this dot helps me label where my ones places. So this is my ones, my tens, my hundreds, my thousands, and my 10,000s. Well, why is there 2 dots? Why? There's 2 dots. There's 2 dots because it doesn't matter which dot you use. It just signifies where the groups are, right? So you could use this dot over here, or you could use this dot over here. It actually doesn't matter. I choose this one so then I can have a larger number. You could choose this one and then you can have a smaller number. But then why is there 2 dots? Because it also helps us group. So when we're grouping, just as we group when we talk about, multiplication, no, not multiplication, as well as we're doing 1,348, right? If you look, we have 1,348. I'm going to turn on my light because this is kind of dark. So when we look, that's what the separators are for. The separators are for to help us, visualize, label, helps us label what the numbers are. Notice, see, 1,348. Make sense? Now, how did I count this? Well, let's start back. Let's take a few steps back. Right? We have 1, 3. Right? 1, 2, 3, then 4. 1, 2, 3, 4. And then what do we do after that? Well, we talked about the 5. The 5 will always be the top bead. So we have 5, 6, 7, 8. So we have 8 right here. I just need to close out some stuff because I'm getting confused. Okay, so And I'm looking and playing around with my stupid camera. Here's my camera. Here's my camera. Okay, good. Now I can see lines. Okay, thank you everybody for liking my lives. Let me know if anybody has any questions. We're just talking about what we're doing is we're understanding how do we read this ancient tool, this ancient Japanese tool. It's yeah. So it's interesting because why is it interesting? Because it helps us count and it helps us understand how we're moving the beads. So what we're going to be doing is we're actually going to be doing some adding, subtracting. Thank you so much for the likes. Let me know if anybody has any questions. But don't forget to share my life if you think anybody would enjoy watching how to count on the abacus. So let's take a step back. Just as we have a die, it's interesting because in school, in kindergarten, we have all these manipulatives to help children understand what numbers are. So here is 4 on my die, and then here is 4 on my throwing a few likes your way. Thank you so much, Old Limey. So here we have 4. 1, 2, 3, 4. So what we're doing is we're just figuring out how to read on the abacus. When we learn how to read on the abacus, we can actually start adding, subtracting, multiply. We can actually multiply and divide on the abacus. But first thing we need to do is we need to take baby steps, baby steps, baby steps. So the first thing I want to know is, here is my number. What number do you think this is? Everybody, anybody in the chat, go ahead and put it in the number in the chat. What number do you think this is? So if I know that this is my ones, this is my tens, and this is my hundreds, what number is this? Ooh, Old Limey, you're on the roll. Yes, it is. Anybody else? We have 157. Easy? Easy, simple to use, easy to understand. I'm going to drill it in. I'm going to drill it in. Why? Because abacus is the gateway to complex math. So what we're doing in abacus is we only do arithmetic. The only thing we do in abacus is we do arithmetic. What is arithmetic? Adding, subtraction, multiplication, and division. That's the only thing we do. So how do we do all this? Let's start talking about like how to start adding, because it seems like that we're ready for some adding. So some adding problems. We're going to do something simple. It's just so we can keep track of stuff, right? So we have 0. Notice this is my 0. Why? Because none of the beads are touching the beam. When none of the beads are touching the beam, this is 0. It's interesting because in school we teach the kids to start from counting from 1. But in abacus, we actually teach the kids from starting from 0 because I want to clear my abacus. That's not clearing. That's clearing. So I clear my abacus so that it's nice and clean. When it's nice and clean, then I can actually start doing some sort of adding, subtracting, multiplying, or dividing. But the first thing we're going to do is we're going to learn how to add. We all know our numbers, right? So in the book that I have, this is my book. It's available on Amazon. We talk about the relationships of the numbers. So here is a few adding. Now, the reason why we want to do this simple addition is just to see how the beads move. And the way I have broken it up is we want to look at the add-ins. Why are we looking at the add-ins? We look at because that's the thing that we're trying to do. So the first thing we're going to do is here. If I have this, I have 1, and then on my abacus, I have 1. And then I have another 1, right, where my middle finger is. This is 2. So I'm looking at it where, okay, this is simple. I'm an adult. I know what I'm doing. It's like, yes, we do. That's not a problem. That's not questioning your adultness. It's not even questioning anything. It's just showing you how the beads move. Because what we do is we think in abstract terms. If you look at these symbols, I almost got, oh, yay, woo! Almost got 1,000 likes. 1,000. 1,000. 1,000. Thank you so much. Thank you so much. So here, what are we trying to do? We want to understand what the beads look like when we move, because we do a lot of understanding what the abstract is, but sometimes we forget what it looks like in concrete form. This is kind of concrete because now we have 2 and I want to add 1. Whoa, there I go. Thank you so much. Thank you so much, Old Limey. So then I'm going to add 1, and then here I go. I add the 1. Notice I'm adding the 1 bead here. This is the 1 bead that we're adding. Now, if you notice, if I have 3, here's my question. I have 3. Again, I'm only adding the 1 bead. Now, why am I doing this? Because I only want to focus in the add-ins. What is an add-in? And add-in is the number that we're adding. So there was one thing I was doing is I was researching on how does everybody else teach children to add and subtract. And so I found this one video, and these are add-ins. It was 5 plus 3. And so in the video, it was kind of interesting because they were like, oh yeah, because we know as adults that this is 8. Yeah, and they were like really focusing on the result. Yeah, this is it. This is 8. This is how we do 8. And I was like, oh, okay. But on the abacus, when we look at it, we have 5, and then the question is do we have enough beats to add the 8? Do we have enough beats to add the 3? Yes, we do, because we have 5, and then 6, 7, 8. Notice there's 3 beats. I'm going to add the 8. Right? So my answer is 8. Okay, not a problem, not a problem. So let's do the next question. The next question they had was 7 plus 1. Whoa, 7 plus 1. 7 plus 1 is 8. Whoa, it's 8. Woo! Again, their focus is the result. So what are we looking at? We're looking at 7, and on the abacus, we're going to add the 1. Okay, not a problem, because we have enough beats to add the 1. We have enough beats to add the 3, right? But notice these are the second add-ins. These are the add-ins that were on abacus. So what happened? The final one they did was this one. We all memorized our doubles. But in abacus, we do not memorize our doubles. What do? Well, there's a strategy, right? Doubles plus 1, and then doubles minus 1. So this is a whole strategy. We actually don't memorize this in abacus. What we do is we figure out what our add-in is. What does that mean? We know that this is 8. Okay, fine. We know this because we've memorized what our doubles are. But in abacus, the first thing we're going to do is we're going to understand our add-in. That's why we do this first. We figure out how we move our beats. When we figure out how our second add-in is, when we figure out our add-ins, then we know how to move our beats. Now, why is this a different question? Because if you notice on the abacus, I have 4. I feel like I'm a little crooked. Oh, I should do this way. Maybe that's better. Okay, so notice I only have 4. Now what do we do? Oh my goodness, what do we do? So what we're going to do is in school, I'm going to reflect a little bit. In school, we're teaching children how to make a 5. So we have 4 plus 1 is equal to 5. And then the other one is 1 plus 4 is equal to 5. Yeah, that's fine. That's great. So what we're doing is we're making a 5. It's also called a 5 frame. 5 frame. So the 5 frame would be 5 frames. 1, 2, 3, 4, 5. And then what we're going to do is we're going to color this in. So we do this, right? Color it in. So that's 4, right? So we have 5. Okay. So, hold on. I'm sorry. Can you clip this? There's no coupon. This is not a coupon. There's no coupon for this. Sorry. Okay, so this is what we're doing. We're doing a 5 frame. I'm going to start teaching my daughter this. Yes! Yes! You know, how old is your daughter? How old is your daughter? I do have one that you can start with. It's called the Preschool Abacus Math. And what we do is we focus in on abacus-driven exercises. 4 years old. You know what? This would be perfect for your child. Why? Because it starts with understanding what the numbers are. It starts with understanding the numbers. And I try to have it where there is a person that's missing. 80-year-old person. Oh my God. They're missing. I gotta stop this. Stop. Sorry. Okay. So what we're doing is we're understanding how to read the abacus and correlate the numbers with the abacus, right? So I have it where, you know, you look for the number and you look for the abacus. Now, what does that mean? Well, just like in here, I'm all over the place because I got interrupted by somebody trying to buy something. All right, so here's a couple of activities. So I have the number, and then what they're trying to do is you're trying to find, and you can choose any path, right? The idea was that they would have fun. This one's available on Amazon. You can find my name. All right, so, okay, so we're adding. Okay. Now, for your 4-year-old, just so you know, for your daughter, I wouldn't do this just yet. This is kind of the next step. But you can start with this. So if when your daughter understands how to read the abacus, yes, I wish I learned this back when I was a child. I'll check out your mother. Yes, you know what? The funny thing is I felt the same way. I actually learned this when I was like super old. Not super old. I take that back. I learned this before I had kids. I didn't learn abacus when I was a child. I learned this as an adult. And so then my dad was like, I want to start a business and we're going to teach abacus to kids. And he was like, but I don't know abacus and you're going to do it. And I'm like, what? What is abacus? I don't know. What? Anyways, so went down this path of understanding what abacus is. And then as I started going through, I was like, oh my God, this is the greatest thing next to sliced bread. Holy cow, I wish I knew this. So I'll continue on with where my revelations come in. But I wanted to let you know. So after you understand, like after you have your daughter understands like the relationships, right? We do counting forward, we count backwards, and what I do here is I give you the number 3, and the idea is to see what the number looks like. If I want to go back, you take away the 1. If I want to go forward, you add 1, right? So if I'm at 3, I add 1. So the idea was to understand the relationships. That's what I was thinking. And, granted, this is my first book. You could do this one. You could do, if you're okay with themes, and depending on how quickly you think your daughter will go, you could go into instead you could do Christmas counting, which is from 0 to 20, and we actually start going to double digits. So it's up to you. I'm not pushing anything. I'm just saying, because some kids are faster, some kids are slower. I have this one student. He came to me when he's 3 years old, and we're still going through this, and now he's 4. And so what we're doing is we're actually slowly understanding how to add and subtract. So the first thing I do right now, I mean, I've had him. He's been in my class for about a year now. So now what we're doing is we're adding. We're slowly adding, and what we're doing is we're taking the add in and we're understanding what we're doing here. So here with my 2, I'm not there. I'm here. 2. And then I want to add the 1. The reason why I show the scenario of adding 1 here is to have it in different ways of how to add the 1. Now, this one is the same thing, but now it's in abacus form because I want to show that it's not just the top bead. I want to show that it's any one bead at the bottom. So all the beads at the bottom. Yes, she would be so excited. She loves, oh, yes, she loves puzzles as well. So I think she'll be heavily involved. Honestly, I love puzzles too. And I think that's why I really like the abacus. And so in this book, I have a little bit of puzzles. You answer the question and then you find the answer. So I was trying to make it kind of interactive. I was trying to modernize abacus. Really, my goal was trying to modernize abacus because some of the abacus books that are out there are really really boring, and I felt sorry for my kids because they went through the boring abacus. And this is what they were going through, and this is like 60 questions of like mind-numbing questions, and I was like, okay, that's fine. So then I'm like, oh, but then I have now, my kids are older now, you know what I mean, like they've gone through the whole abacus curriculum, and they got into the whole abacus curriculum. I'm a little crooked. I'm just trying to readjust. So they went to the abacus curriculum, and it took them. We went through from adding, subtraction, multiplication, and division. So you can go all the way to division and doing decimals on the abacus. It took them a while. It took them about 3-4 years. 3-4 years, yeah. Because we weren't really focused, right? Like, I'm not here to be like, you got to go to abacus competition and be the best and do the greatest. No, I was like, you know what? I want you to understand what the abacus is, and I want you to be comfortable with math. That's all I wanted. So that's why I started this. That's awesome, Lynette. Thank you so much. I appreciate it. And that was the point. Like, the idea was to be a little bit interactive and be a little bit, kids, right? Nowadays we're different. Right? Before it was just like drill and kill kind of a thing. But it's like now there's ways to talk about it. But I do add I do add like pages of adding, right? I mean, we still got to go through that. I feel like we still need to go through it. So it's not just all activities driven, but it's kind of nice. A little break, a little bit here and there. So this one is about simple. Now, what does simple mean? Simple means that there's no formulas involved. So I was just digressing from from what I was talking about before. So the reason why is because what we do is we ask, okay, is there enough beads? Yes, there is. So we're just going to take away the 3 beads. That's what we're doing here. We're taking away the 3 beads. So my add-in is 3. No, sorry, my subtracted. And there's all these terminologies that I started learning going down this route to teach adults what we're doing here. Because kids don't know the word subtracting. I mean, you could start talking to them about it, but really I think it's a little bit complex. Just knowing the terminologies. But I mean, it was interesting. Anyways, so here we have 9. How do I know? 5, 6, 7, 8, 9. Right? We have 9. And then what I want to do here is I want to take away 3. So I'm going to take away the 3. 1, 2, 3. So then my answer is 6. So the idea here is to write the answer 6. So whatever the answer is on the abacus is the answer that you put in the question, if that makes sense. Sometimes the kids, I mean, I put boxes here because sometimes the kids were like, I don't know where to put my answer. So this one I was trying to think like maybe they need help. And it kind of goes like back and forth. But this was my first book, and I'm making more books. So the other one, so after this is the plus 5. So I broke it up into plus 4, 0 to 4, right? 0 to 4, and then 5 to 9. So then we have the plus 5, and then after adding the 5, we minus the 5. If you add, you need to subtract. It's just one of those things. In Abacus, we have a balance. We have adding, and then we need to know how to subtract. So here is adding the 7. There's not a lot of questions for adding the 7, but then we have we have questions for taking away the 7. Again, we don't have a lot of questions, but at least they see the difference, right? So here I have, what number is that? I have 8. I'm going to clear my abacus, and I have 8. So I have 8, and then I have 7. I take away 7. 5, 6, 7. So I take away 7. These are the beads I need to move. I'm going slow because sometimes I go too fast and you can't see what I just did. So these are the 2 beads. It's the 5, 6, 7. So when you move it, these are the beads that you're moving. Obviously, the kids are not going to go that slow. but because we're trying to visualize and understand what we're doing, this is the minus 7. So what we did is we have 8 and then minus 7. We're moving these beads. Make sense? So let me know if you have any questions. We're going to continue on. So here was the question, right? The question was 4. Now, what is 4? We're going to make a 5. Why are we making a 5? Because if you notice on my abacus, I don't have enough beads for 4. My question is 4 plus 4. We've memorized we've memorized our doubles. But in Abacus, we don't memorize doubles. What we do is we memorize, oh yeah, it makes sense. Yes, right? Simple to use, easy to understand. Yeah. So, now if you noticed, I don't know. Well, when your child goes into into kindergarten, first grade, and so forth, they're starting to do this thing called make a 5. Now, making a 5 is just how do you make a 5? Whoa, what did happen? Oh, maybe that was me. Okay, so make a 5, right? We have 1, 2, 3, 4, 5. You can even use your hands, right? 1, 2, 3, 4, 5. The idea is, how do you make a 5? Well, if I do a 4 plus 1, it makes a 5, right? 4 plus 1 is make a 5. Or 1 plus 4 makes a 5. I don't teach with bricks. This is I don't teach with bricks. I teach with the abacus. So my goal was to get to understand how to use the abacus. The reason why is because we want to use this 5 right here. This is the 5 we want to use. But in order to do that, we need to figure out this part here. So sometimes maybe you start off with these bricks and then you graduate to the abacus. Oh, somebody did say it's like tally marks, right? You do tally marks. 1, 2, 3, 4, and then 5, right? That's what this is. You could do that, but you cannot break the 5. I'm telling this, you cannot break. You cannot break this. So that would be the 5, right? And then we have 6. That would be 6, right? Okay, so we're back to here. 4 plus 1 is equal to 5. Okay, now, is it suspenseful? I'm just building the suspense. What are we doing? Why are we doing this? Now, okay, what we're going to do is we're going to isolate the variable. This is a very big word to say. We're going to rearrange this so we can use it. Why? Because this is what we're going to do. If you notice, I'm going to rewrite the question. I'm going to change my pen. Maybe this will be better. Plus 4, right? This is what this is, right? Plus 4 is equal to plus 5 minus 1. How did I get that? Well, what I did is I took this and I moved it to this side of the equation. Whoa, oh, that's really bright. Maybe that's better. I don't know. I'm always playing around with this. Okay, so this is what we're doing is we're trying, and this in Abacus is called a formula. If you, formula. So in Abacus, it's called a formula. And now what we could do is we can actually utilize this. Why do I say plus 4 plus 5? The reason why we say it is so we remember what we're trying to do. We're trying to add this 4. We're trying to add the 4. In order to add the 4, we're going to add this 5, and then we're going to take away the 1. So if I go back to my question, I have 4. Now, when I have 4, I need to plus the 5 and take away the 1. I'm going to plus the 5, so I plus the 5, and I take away the 1. And my answer is 8. My answer is 8. But see, the thing is in the video, they're like, yeah, we know how to make an 8. But in Abacus, we don't focus on the result. What we focus on is the add-in. We need to know how to add. We need to know how to use how to add the number. Why? Because in algebra, we start talking about the process. We don't talk about the result. So it's interesting in school, in elementary school, they're starting to really enforce, like, how do you get the result? It's like, no, hold on, step back. How do you get to the result? What is the process to get to the result? So that's why in Abacus, we focus in on the plus 4. So why do we do that? Well, because we need to know how do we add the 4. So, Dave, I'm hoping your name is Dave because it says Dave 3. So for your daughter, after she finishes this, the next book would be How to Make a 5. And I made it specifically because I was thinking the path that the children would go. The reason why, because in Abacus, we start children at the ages of 5. And I was like, no, we need to start it when they're younger, when they're starting to learn how to add. No, starting to learn how to count. I don't know why we don't start from learning how to count, but we should. So that's why I made it the activities. This is why I made the book, because I felt like because I know that there's a gap. Because there's a gap of getting the kids in the younger ages to understand how to read the numbers and use the abacus. I mean, we use a die. Why can't we use the abacus, right? We use these bricks. Why can't we use the abacus? So this is my goal. My goal is to introduce abacus to younger kids, older kids, to adults, and to seniors. So, but the reason why I'm going down this path is I wanted to let you know that the second book would be how to make a 5. And so I go through some of the scenarios. So I show like the number lines. Abacus, we don't worry about number lines, but in school I wanted to show the number lines because, I want them to get used to seeing how abacus relates to math, how abacus relates to, school and math. And so do they get confused? No, I don't think they get confused. My boys, my boys, they did abacus, and when we were doing Common Core, they were perfectly fine because a lot of abacus is what Common Core is doing. Welcome, everybody. Welcome. Let me know if anybody has any questions. I don't see who is here. I don't see who's here. So I'm just going to keep on going. I'm going to keep on keeping on. So let me know if anybody has any questions. So we're talking about the number lines. In Abacus, we don't talk about the number lines. So, but what I did talk about is these cats in the tree. So one of the things was, and then I talk about the number bonds because I wanted them to know that they're related, right? So the 4 and the 1 is related. Hi. 4, here's my 5. My number bond is 4 and my other. So they know that these are connected. Right? So once they know, that's the only reason why I brought in the number bonds, because I wanted to show them that connected. So here's the question is plus the 4. When we add the 4, notice that I have the different scenarios. So because I'm thinking that the child is young, after they finish the preschool math, after they go to the preschool math, they're going to go into the plus 5 with who? So the question is 2 plus 4. Now again, we're going to add the 4. Is there enough to add the 4? There's not enough beats to add the 4. So what are we going to do? We're going to go to the 5. Oh, you can't see my fingers. We're going to go to the 5, okay? We're going to go to the cats in the tree. And I made it into a little story because, we all like stories, right? I like stories. So what I did here is I said, okay, we're going to go to the cats in the tree. And then one of my students like, why are there cats in the tree? I go, haven't you heard? Cats love trees. So We have 5 cats in the tree, but that's the thing, right? We always have 5 cats in the tree. We have 5 cats in the tree. So what's going to happen is I'm trying to get 4 cats. So I grab 4 cats. So I grab 4 cats, right? When I grab 4 cats, 1 cat runs away. So when 1 cat runs away, so I go to the cats in the tree, I add the 5, and then 1 cat runs away. So when 1 cat runs away, I move the when 1 cat runs away, I move the 1 beat down. So now my answer is 6. Does that make sense? So that was the one thing I did here, was to make it into a story. So that was the one thing that really stuck to my student's head, was how do I make a 5? And so he realized, well, if I don't have enough beads to add the 5, then what I can do is I can go to the cats in the tree, and then I add my 5, and then I take away the 1. So here's another scenario, right? I have 3. My question is do I have enough beads to add the 3? No, I don't. So what do? I have to go to the cats in the tree. So here I go, cats in the tree. I go to the cats in the tree, right? And I'm going to add 4. So I grab 4 cats. So I go to the cats in the tree. I grab 4 cats. But 1 cat runs away. So 1 cat runs away. And my answer is 7. Make sense? Woo! Oh my goodness. Thank you so much for joining. Thank you so much for joining. We're talking about abacus and understanding how to add and subtract, multiply, and divide on the abacus. And depending on how many people are here. I'm not sure. If anybody has any questions, let me know. If you don't know how to read this, let me know. Because I'm just going to continue on. I don't have any questions. Nobody has any questions. Except for where to find the book. The books are on Amazon. You can find my name. You can look for my name. My name is Lynette. Welcome, welcome. I am here to help you understand how to use the abacus. And sometimes I talk a little fast until I, calm down a little bit. Wow. All right. So we have 7. How do I know that this is 7? Because it's 5. The top bead will always be 5. Okay, so 5, 6, 7. Now, why am I here? Because I have a dot, and this dot tells me the location. It tells me where it labels the ones place for me. So I have my 1s and my 10s. I can, if you want, I can do here, right? So this is my 1s, 10s, 100s, 1000s, and then 10,000. Let me know if anybody has any questions. Ooh, live chat. All right, so I'm on my desktop, and so just so you guys know, I'm on my desktop, and I feel like this TikTok Live Studio app is not as good as I think it is. So there was a few times I was lagging, and it was like, oh my God, why am I lagging? Okay, so if I'm lagging, please let me know, because I don't want to lag, and if I'm lagging, then I have to switch over to my phone. But that's what this is. So what we're doing is we're adding, subtracting, multiplying, and dividing. But the first thing we need to do is we need to understand how to read the abacus. So when we read the abacus, we have 5, 6, 7, and then we have 8, and then 9. Anybody have any questions? 9. So after 9, we have 10. How do we know what 10 is? Well, just as we write 10, we have our 1s, our 10s, and our 0, right? This is our 10s and our 1s. So we have our 10s and our 1s. So this is how we write 10. 1 and 0. Now, why am I here? I'm here because I said that this would be my 1s place. You could do this one over here. You could use this one. That's not a problem. So what it would look like is 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. Anybody have any questions? Woo! All right. So, it was a whole flood of people, but then I think a whole flood of people left. All right, which is fine. Anybody have any questions, let me know, because we can continue on. So thank you so much for sharing my live. Thank you, Whitney, for sharing my live. Okay, so if we're talking about this, so the question, anybody have any questions? How do I know that this is being counted? This bead is being counted. I know it's being counted because it touches the horizontal bar. I'm going to start from the beginning because I'm not sure how many people are. Thank you so much for the heart, Albie. I'm not sure where people came in from. So I'm going to start counting again. How do I know that this is the horizontal bar? This horizontal bar tells me that I am counting, right? So right now, all of the columns, these are columns, all the columns is 0. Because the columns are 0, we have 0. Not a problem. So now when we count, it's 1, 2, 3, 4. So now I have 4. How do I know? Because now all of these beads are touching this beam, right? They're all connected and they're all touching this beam. Notice that these are all zeros. You could do 4, 4, 4, 4 and 4, right? It's the same thing with the 5. Well, where is 5? Well, if you know that this is 4, where is 5? 5 will always be the top bead, no matter what. That will be the top bead. Why? It's just that's the way it is. The top bead will be will always have the number of 5. So then we can count 5 and then 6. We have 5, 6, 7, 5, 6, 7, 8, 5, 6, 7, 8, and then 9. See, simple to use because it's easy to move the beads, right? It's easy to move the beads. And what we're doing is we're just adding the beads to count more. So what we're going to do is we're going to do 10. How do I know what 10 is? Well, if I know that this is my ones place, this is where my ones is, that's where my dot is, then I do my 10. My 10 looks like this, 1 and 0. Thank you so much for liking my live. Panagiotis. I think. I'm hoping I said that correctly. So this is my 10. I have 11, I have 12, and then 13, and then 14. I have 15, 16. Oh, good. Good. Thank you so much. Okay. I did say it correctly. Panagiotis. Okay. 16, 17, 18, 19, and then what's after 19 is 20. Just like as we write it, 2 and a 0, it's 2, 0, 20, 21, 22, 23, 24. So if anybody has any questions, let me know. I mean, you came on board. I just want to make sure we all understand. Anybody have any questions? Oh my God, Andrew knows! You're here! All right. We're still counting on the abacus. What are we doing? We're doing 25. 25, hello. Hey, yeah, 25. So we got 25 and then 26 and then 27 and then 28. Yeah, 28. And then we have 29. We're just counting on the abacus right now because I'm not sure where everybody is. We have 29. Just like we write. So when we're writing, let me write it. I need to find like nice paper. Not nice, but like clean paper. So here, just like how we write, we have the number, let's say 245, right? So we have our ones, we have our tens, we have our hundreds. So we have 245. Okay, so let's add another number. Let's do that number. What number is that? That number is 5. So notice I have a comma here. That's why there's a dot. So if you look at my dots, ones, tens, hundreds, thousands. This is going to be my thousands. That's why we have a comma here. It doesn't mean anything, right? It's just helping us to differentiate and separate our groups, right? And it's the same thing with our hundreds and millions. Well, we can't really do millions on this one. This one would be for the kids that are young, because after a while the colors get a little bit much. So what I would do is I would graduate them to a 13 column one with single colors. The reason why is because, the kids will be like, whoa, I'm a big person now. And so it'd be nice for them to, graduate to a bigger number, to a bigger abacus. And this one is 13 columns. So if you notice, there's all these dots. There's a lot of dots, right? And again, these are group separators. So if we started here, this would be thousands, and then this would be millions. I would start here. I usually start in the middle because it's a bigger abacus. So what I would do is I start in the middle because I would have all of these digits. I would have all these columns. I would have all these place values. So I can be a big number or I could be a small number. Right? So let's do a big number. So we did this number. How does that work? Well, we do 5, 4, 2, and then 5. See how my dot kind of aligns with the comma? So if this is my ones, this is my comma. We could do millions, right? How does that look? Well, if I do 3, I have 4, I have 1, I have 5. I have 4, 2, and then 5. So this is my millions. If I said that this is my ones, then this is my millions because it's ones, tens, hundreds, thousands. You know, abacus is really easy if the person teaching knows what they're doing. Oh, thank you, Andrew. Yeah, see, Andrew knows. Andrew did say though he didn't know, and I'm like, Andrew, you do know. So yeah, so it's ones, tens, hundreds, thousands, 10,000, 100,000, and then 1,000,000. Thank you so much for the hearts. Thank you so much for the hearts. So, Panagiotis, do you have any questions? I mean, I only see Caddy and Andrew and Panagiotis. Let me know if you have any questions because I can answer any abacus questions. Any abacus questions. Thank you so much for the likes, Andrew. Thank you so much for the likes. Okay, I can bust you out. Only the best 100. So, and that's not a question. I'm okay. Thank you. Okay. So, only the best 100. I'm gonna bust you out if you're gonna continue to be obscure like that. So we're gonna continue on with this. So we have our ones, our tens, our hundreds, our thousands, our 10,000s, our 100,000s, and our millions. So this is how we're reading on the abacus. I'm gonna go back to the colorful one just because I like color. I've been teaching abacus for more than 20 years, and we've dealt with a lot of the. I clearly see that the rain has gone. I've been dealing with the single color ones. It's easier for single color because it might be the colors might be overwhelming. In the single colors, having, being in person, the single colors is just fine. I have my abacus class online, so it's easier for me to say to the kids, let's move the colorful beads. And, one thing is I'm going to be like, move the brown bead, but here they're all brown. So it doesn't make sense. But here we're going to do the same thing. We can do the same thing, but we can only have up to the 10,000. So I'll do the 3, the 4, the 1, the 5, and then the 4. So notice I just have this many beads. You could start from here, but then you're a little bit lopsided. Why? Because there's no dot here. What happens on these ones? This is where we do the decimals, right? So we have our number 4, 5, comma, 1, 4, 3, period, dot, period, decimal, and then we can do 25. How do you do multiplication with the abacus? Whoa, we're graduating now. We'll do multiplication. We'll do multiplication because it seems like it's a small crowd. So I'm just going to keep going. So right now I'm just talking about, let's do this, and then we'll go into multiplication if nobody else has questions. If you have questions on how to add, we could do that too. But for right now, we'll do 25. So we do 20 and then 5. Why? Because this decimal, right? This decimal happens between, notice it doesn't sit, but it only sits between the two columns. As it sits between the two columns, right? That's where the decimal is. And that's the only thing. The decimal does not take a place value. So that's why this is not a decimal, this is not a decimal. It sits right in between, if that makes sense. All right, so let's do some multiplication. Well, the biggest thing is, children, whoever does multiplication, we need to know our multiplication facts. However, we don't need to know anything higher than 9 times table, because after 9, it gets a little redundant. So what we're going to do first is we're going to do 12 times 6. This is easy, right? Not a problem. What we're going to do, and we'll do step by step, because there's no point of doing a huge number if we don't know the basics. So what we're going to do, monkey sees, not real monkeys. Sea monkeys are not real monkeys. Well, yeah, true. Sea monkeys are not real monkeys. So what we're going to do first on the abacus, what we're going to do is we're going to find our starting point. Why? Because we need to understand where are we going to put our numbers. Okay? So because we have to know where to put our numbers, what we're going to do is we're going to go from left to right, because it just seems more, to me, it just seems more, it's forward. So what does that mean? The first thing we're going to do is we're going to count our digits. 1, 2, 3. So now our starting point is at the third column. Starting point. At the third column, what is the third column? It's the hundreds. 1, 2, 3. This is our third column. So our hundreds is over here. Now we're going to start knowing how to multiply. right? We know 6 times 1 is equal to 6. 6 is a single digit. So what do? We actually have to go back one column. So I move my finger one column back because it's a single digit, and I add my 6. Easy? So then I did this. So what we're doing is we're doing it's called distributive property. So we do it in algebra, but in Abacus we also introduce it. And again, Abacus is the gateway to complex math. And so you'll see as we go through Abacus, we actually touch in and introduce like different scenarios, different concepts, different frameworks, different methodologies that happen. So this is distributive property. The next thing we're going to do is we're going to do 2 times 6. 6 times 2, 2 times 6, it doesn't matter, right, is 12. So we're going to add the 1, and then we add the 2. And that's it. So my answer is 72. That's how you do multiplication. The reason why that's why we don't memorize anything higher than 9, because it gets confusing. Okay, let's do it the other way. What's the other way, Lynette? The other way is if we were to do it the school way, right? The mainstream way. The mainstream way is we do it this way, and then we have a 6. The first thing we're going to do is we're going to touch on the ones first, and then we're going to do the others. So notice when we do the ones, we know that this is 12. But when I start it, I'm going to start at the ones. I need to figure this out. I need to start at the ones. But when we write 12, we got to go forward and then go backwards, if you see that, right? So we go back and we have to go back and then go forward. That's what I mean. So it's getting a little confusing. So I had my 1 and my 2. Okay, but my finger is here. Because my finger is here, what do I do with this when I do the 1 and the 6? Well, now I got to go back and then I add my 6. So my answer is 72. But notice it's a little bit of backtracking. And that's why in Abacus we don't do it this way. In Abacus we do it horizontal, and we figure out where do we start, and we move from left to right. Left to right. So that's what my hands are doing. I'm going from left to right, because on the Abacus we go from left to right. Oh yeah, see, that's the difference. The difference in mainstream math is different than Abacus, and it's really interesting. So we can take it one step further. Let me do two digits, right? 12 times 63. It's the same thing. Oh yeah, be right back. Not a problem. So it's the same thing, right? We have to count our starting point. 1, 2, 3, 4. So what are we going to do? We're going to do the same thing. 1, 2, 3, 4. We're going to start in our thousands. We're going to start in our thousands. Again, we're going to do this. 1 and then 1. So we're going to do 6 times 1 is equal to 6. 6 is a single digit. I go back one column. So now I add my 6. Right? We're just doing the same thing. 6 times 2 is 12. So I have my 2 and then I have my 1 and I have my 2. Now, I'm done with the 6. I don't need to worry about it anymore, right? I don't need to worry about it anymore. So what am I going to do? I got to recount my starting point. So I got to recount it. I'm going to use a different color. Let me use a different color. That's not right. This is right. Okay. So I'm going to use a different color. So now I got to still do the same thing. I still got to do distributive property. Distributive property. I do 3 times 1 and then 3 times 6. So what am I going to do? I'm going to 3 times 1 is equal to 3. Where did I start? I have to start at 3. 1, 2, 3, because I have to count my digits. I don't count the 6. I got to count my digits, my leftover digits. So that's 1, 2, 3. Now I'm going to add 3. Do I add 3 here? No, I do not add 3 here. Why? Because 3 is a single digit, so I got to go back one column. So I go back one column, and remember, do you remember how to add the 3? When we add the 3, we have to plus the 5 minus 2. Just as we said before, we waxed on and we waxed off. Somebody said that. I don't know if you were there for that, but somebody called me Mrs. Miyagi, and I started correlating that if you know your 5 formula, right? If you know how to make a 5, you're waxing on. And then when you do a -5, you're waxing off, just like in Karate Kid. All right. So back to this. We have 5 minus 2. So I'm going to add the 5 and I take away the 2. Now what do? We do 3 times 2. 3 times 2 is 6. 3 times 2 is 6. I'm here. So what is 6? 6 is a single digit. So what do? I go back one column and I add my 6. Whoa, that was easy. So what is my answer? 7, 5, 6. Yeah, that's my answer. Oh my God, that was an easy one. Okay. So I actually haven't done it. I haven't done this the abacus way. Okay, sorry. I haven't done like this in the school way with an abacus. So let's see. It's different because we're doing this, right? And we got to line things up. Let me line it up. All right. So the first thing we're going to do is this is how they do it, right? 6 times 2 times 3 is 6. So I'm going to put my 6 here. Now I'm in my tens. So if I go my tens and then I have to do the 3, right? So I add my 3. Okay, fine. So I've done this. See, now I'm confused. I don't know if I have to go back to the ones and then here. See, that's why it gets confusing if you do it this way in regular math. I think you have to start in the tens. So 6 times 2 is equal to 12. So I think I need to plus the 1 and plus the 5, plus the 2. Plus 2 is plus the 5 minus 3. All right. And then I have to, well, I guess you could, but it's backwards to me. So because I'm here and 6 times 1 is 6, but 6 is a single digit, but I have to go back here and I add it. Yeah, I don't know. I don't teach this way. I teach this way. This way is better for me. This was just a test to see how it goes. So, hey Dandelion, how's it going? Welcome. So we're just talking about multiplication. Any more question, Andrew? Well, I mean, we could do more multiplication. We could do, we'll do another one. Let's do another one. Let me see if I can find another one. We could do, let's see. We'll do something simple. All right. Here's my abacus. And we'll do fives. Fives are really easy, right? 73 times 5. 73 times 5. If we do 73 times that 5. Hi. We're just doing multiplication. So what do? We have to find our starting point again, right? So this is horrible. I've been lagging since yesterday. You know what? I might actually not need to work with this one. I got to figure out how to do it with StreamYard. 1, 2, 3. So what am I doing? I'm going to do 5 times 7. 5 times 7 is 35, right? So I add my 3, and then I go here and I add my 5. What's next? 5 times 3. 5 times 3 is 15. What do? I add my 1, and then I add my 5. Oh, that was easy. So, in the comments, let me know what answer this is. What answer is this? What number is this? What's the answer? So if I do that, let's do that. So what answer is this? Put it in the comments. I don't know if I have really 5 people or if I have more or less. I don't know who's in. I'm just letting people know. So if you're still here, let me know in the comment what this is. So if this is my ones, my tens, my hundreds, yes, Mata, yes, 365. Exactly. And that's how we count it on the abacus. But that's how we do multiplication on the abacus. Yes, Dandelion. If that makes sense. Yeah. Let me know if anybody has any questions. I mean, I can carry on. I was actually thinking about what I was going to do for adult introduction to Abacus for adults. And I was going to create a workbook for it. So I have a workbook for preschoolers. I was going to make a workbook for the different grades. I started thinking, okay, I think what I need to do is I'm going to make a, I don't understand the moving over. Oh, so, excuse me. Understanding the moving over. Okay, so when we're doing things, right? So let's go to here. Here is my thing. When we work with our numbers, we don't work with place values of the numbers. It might be easier for you, but then it gets complicated really quick. So what does that mean? Well, when I look at my abacus, I have my numbers. So the first thing I'm going to do is I'm going to do 35, right? So notice I add one bead here. I add my 3 here, right? To make 35, I add my 3 here, and then notice I need to go to the next column to add here. That's fine, right? So now what I'm doing is when I do 15, it just stacks on top of each other, just how we do adding. But notice I have a 0 here and I have a 0 here. Does that make sense? So as we add, we do 15. I add my 1 and then I add my 5. So instead of writing it out, I think that's what it is. So instead of writing it out, when we, in Abacus, instead of writing it out, we actually do partial product. What we do is we do partial product, and it's right here on the Abacus. So if we do another question, let's do another question. 53 times that by 4. Is that what you mean by moving over, like when we're talking about multiplication? Even when we do adding. Even when we do adding. Thank you so much for following me. Okay, so multiplication. Multiplications is same thing. So again, we're gonna find our starting point. So we gotta start from the beginning, right? We're gonna find our starting point. 1, 2, 3. 1, 2, 3. So now I do 5 times 4 is equal to 20. Notice it's a 2 and a 0. I'm gonna write it out. 2, 0. If I write it out with here, it'd be 2, 0, 0. So this is what's happening, right? 2, 0, 0. So I have the 2 and I have a 0 and a 0, right? You could say 50 times 4 is equal to 200. You could say it, but in Abacus we don't, because the zeros are already being tracked when we do it on the columns. Okay, so now notice I have a 0 here. I have to count. I have to make sure that I account for the 0. So that's why I move my finger to the next column. Because this is 2 and a 0, 20. So now my number that I'm doing next is 3 times 4. 3 times 4 is 12. Just as I write, this is one column, this is the next column. As we do the separate columns, I do my 1, and then this is 1, this is 12. So I got to do my 1, and then I got to go here and I add my 12. Did that make sense? So then now my answer, when I put it all together, is 212. Because what in Abacus, we don't need to write it out. We don't need to stack it like this. It's already on our Abacus. So when you're showing your work, you might want to keep a running total. If you keep a running total, then you can see, we can see it with our numbers. But yeah, that's what this answer is. Did that make sense? That's why we do the moving over. We do it because of the numbers tell us. If you can see what the numbers are telling us. I really like The Rock. I liked him when he was at WWE. When I did the double... No. Was it more complicated? No. It wasn't more complicated. It's the same concept. It's just we start over again. So let's do double digits. So let's do 54. Let's do 53 times that by 47, right? It's better to have different numbers. So the first thing we do again is to find our starting point, right? Our starting point is 4. 1, 2, 3, 4. No, yeah, it's not the same. It's all the same. It's just not. It's not that complicated. Because if you look, 1, 2, 3, 4. So our starting point is 4. The first thing we're going to do is 4 times 5, right? 4 times 5 is 20. 4 times 5 is equal to 20. So I do my 2, and then my 2 and my 0. And then my next one is 4 times 3 is 12, right? That was a horrible 2. There, 2. So again, it's 1 and then 2. Okay, I've already multiplied out the 4. I don't need to see it anymore, so I'm going to cross it out just to visually understand. What I'm going to do now is I'm going to reassess and restart my starting point. Why? Because I need to figure out where I'm going to put my next partial product. So here, I'm going to change a different color because it might be easier. Maybe I'll do this color. So now we have to reassess what our starting point is. When we reassess our starting point, it's this one, 1, 2, 3. So my next starting point is 3. 1, 2, 3. So now I have 7. 5 times 7 is 35. So I add my 3, right? I add my 30, and then I add my 5. This is my 30. I'm going to go here to add my 5. And then finally, I have 7 times 3 is equal to 21. Ooh, that worked out really well. How do I know? Because I just add 20, right? I add my 20 because I was here. I ended up here. 20 and then 1. So then my answer is, what's my answer? In the chat, let me know what the answer is. But yeah. 2,491. Yes, exactly, Dandelion. So question is, did that make sense with the double digits? It's the same thing. It's just what we need to do is just we need to reassess. That's all we're doing. Multiplication is quite easy. That's all we need to know for multiplication. You can add in more numbers, and it doesn't matter. You still got to go through the same process of distributive property. And that just means that you're going to go one right after the other. And as you go through one right after the other, you just do a process of elimination. So doing the only reason why multiplication is more complicated is just when we start adding everything. And then adding the numbers is where it starts to get complicated because you can do two-step equations when we add and subtract. But that's why we need to really get solid in our adding and subtracting for making a 5 and making a 10. Yeah. Let me know if there's any more questions. Yeah, so this was actually a nice one because there was no extra thing. How do you know where to start on the abacus? Is it always how many numbers there are in the operation? Yes and a no, Mata. It depends on what you're trying to do. If you're trying to just add, then you start in the ones column, right? So if we're adding or subtracting, we always start at the ones column, no matter what we're trying to do. So here is a question, right? If I did a question, let's do like 59. 59 plus 36 plus 33. Now in school, we are teaching the children to do our ones first, right? And then our tens first, which is fine. Hey, hi, Ethan. I'm lagging still, and it makes me mad. I think I need to transition out of my, off my laptop to my phone. So going back to Matta's question, now in school, we're teaching the children to do ones and our tens, but in Abacus, what we do is we do like as a number as a whole. We do ones, we do the top, and then we do the second add-in. So what does that mean? So again, as we see the numbers where we start, so 59 and then 36. So we add 30 and then we add 6. Now we have to go into complicated math because I didn't go over like how to make a 10. But in this scenario, I'm going to add 6. Add the 6's, plus 6 is equal to plus the 10 minus 4. This is something you have to memorize. So we add the 10 minus the 4. And then notice I go step by step. So now I do this. I want to add 33. I add 30 and I add 3. To add the 3, is there enough? No. I need to plus the 3 is equal to plus the 10 minus 7. So I plus the 10 and I take away the 7 and then I add the 3. Now this is what we do for adding and subtracting, right? It's all the same. Doesn't matter, right? But in multiplication, 1, 2, no, actually 7, 8. You're forgetting the 5 up here. So, Matta, when we talk about multiplication, yes, we need to figure out what we're trying to do. In multiplication, we need to know where our starting point is. That's why we start counting our digits to know where we're going to put our answer. Ethan. Yeah, for now, I'm not lagging, but I did see it sometimes. So going back to the question, where do you start on the abacus? So that's how I know. So in multiplication, I know I'm going to start on the hundreds column. And now it depends. In division, it's different as well. Division, we have to figure that out as well. So in division, let me see if I can find a division question. So we're going to do some division. So when we do division, it's the other way. In multiplying, when we multiply, we add our digits, right? We add the digits, 1, 2, 3. When we divide, let's do 2 divided by 58, we do subtraction. This is an old, okay, that's gonna go. So here, we're going to take our digits and we're going to take away. Now when we take away, it's 2 digits, take away 1 digit, right? 2 take away 1 is equal to 1. So our starting point now is different because we're doing division. So our starting point is here. We're going to have our answer here. What I'm going to do is I'm going to put my dividends over here. I'm going to call this E. Why? Because dividend, DE, dividends, right? So 58. Why am I putting my finger here? Because this is where my answer is going to be. This is my divisor, and that's what I'm going to say. So now the question is we have a conversation with our answer. We have our conversation with our question. Who is bigger, the dividend or the divisor? So if I do this, the dividend or the divisor, the dividend is 5. The divisor is 2. My dividend is bigger. So if my dividend is bigger, I only use one column. That is a rule that we need to know. So if we use one column, we have to skip one column. That's where we do the skipping and moving. This is something that we have to memorize. This is a rule that we have to memorize. If the dividend is bigger than the divisor, we need to skip one column and use one column. So my question is, 2 times what is equal to 5 or less? We do 5 or why we do it this way is because it's easier to understand what multiplies to 5. We know what the product is. We just need to know what our missing factor is. I feel like it's different to say how many times does 2 divide into 5. I don't talk like that, right? So yes, exactly, 2. So I'm going to put my answer 2 over here because that's what my answer is. And then I have to take away 5. When I take away the 4, because 2 times 2 is 4. That's something that we know. 2 times 2 is equal to 4. I take away 4 and I take away, and it'll be 1. So notice I'm running out of space. 2, I still have a divisor. Let me slowly move this out and move my paper. So we still have our dividend question, right? Why do we still have dividends? If you notice, I'm slowly moving it up because I don't want to lose my number. Don't lose my number. It's that Phil Collins song. Na 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 na. Anybody can you? Hey. Okay, Billy, don't lose my number. There we go. That's what it is. All right. So my dividend and my divisor. My dividend is 1. We only need to compare one number. We only need to compare the first number in our dividend. So this is our 1. And our divisor is 2, if we remember, right? Our divisor is 2. My question is 2 divided by 58. That's my question. So I'm here. We already did the 2. This is my 2 here. So we bring it down. It's 4, and then we have 8. Notice in here, in school, we say, okay, well, how many times 18, right? That's what we say. But in Abacus, we take it, we bring it down a notch. We make it more simple. We question, who is bigger, the dividend or the divisor? See how there's a connection? So when we know this, we know, are we going to take two columns or one column, right? So, and that's the thing, like, I feel like that we're missing a few steps when we do long division. I feel like we're missing a few steps because how do we know what we're trying to do? So this is the rule that we're doing in Abacus. In the rule of Abacus, if the divisor is bigger than the dividend, then we know we're going to use 2 columns. Hands down. If the divisor is bigger than dividend, it will always be 2 columns. So what is the 2 columns? These are the 2 columns. So now we have our question. 2 times what is equal to 18 or less? Do you see how easy it makes? Like, it really boils down to what we're trying to do. Like, I don't want to have to assume what I wanted. I don't want to assume. How do I know I'm going to use 2 columns? Because my divisor is bigger than my dividend. So there's logic behind it. 9. 2 times 9. 2 times 9 is 18. So I take away 18. 2 times 9 is equal to 18. So my answer is 29. But what I'm saying is here, when we know if our divisor is bigger, we know if we need to do 1 column or 2 columns. And I think we need to be a little bit more obvious. And it's just a strange thing. Wait, shouldn't it be 1 column? No, because it's one. No, no, because we're doing is the divisor. This is the divisor. This is the dividend. When the divisor is bigger, right? You can't just do 1 column like this, right? We can't just take away. We can't do 2 times what is equal to 1 or less. That doesn't make sense. It should be 2 column. So because the divisor is bigger than the dividend, it's 2 columns. If it's the other way, if it's this way, if the dividend is bigger, let's say 5, then it is 1 column. So that's just a rule. If the divisor is bigger, then it's 2 column. If the dividend is bigger, then it's 1 column. But then we put our answer here, right? Your answer will be your answer will always be 1 column. It will never be 2 columns. But we have to be careful because in dividing we also have a higher math. Just got here. How is 2 bigger than 58? It's not. 2 is not bigger than 58. 2 is smaller than the 5. So what we're doing is we're comparing only the 1 digit. You only need to compare 1 digit. So when we compare the 1 digit, who is bigger? So in the beginning, we had our divisor and our dividend. I like to label it, and I want to see because I get confused really easily. I'm easily confused. So here is our divisor and our dividend. When we compare, we're only comparing the 1 digit. That's the only thing we're going to do. So when we compare, just like that. So our divisor is 2, right? And our dividend is 5. Now we can say, okay, do we do 1 digit or 2 digits? If the dividend is bigger, like this, if the dividend is bigger, then we only use 1 column. If the divisor, okay, so we're going to do it again. We'll do it again. So we find our starting point, right? Our starting point is 2 minus 1 because what we do is we combine the 2 and the 1. So we do 1. So my answer will be here. My answer will be here. So I'm going to put 58 into my abacus so we can do subtraction. So now the question is who is bigger, my divisor or my dividend? My dividend is bigger, so I use one column. So I'm going to skip this column because I'm going to put my answer here. And I'm going to multiply out to the one column. I'm only going to use this one column to multiply out. So the question is what times 2 is equal to 5 or less? Good morning, Amma. I didn't greet you in. Okay, so 2 times, and I take away 4. So now this is where we compare our one digit to our divisor. We compare our rest of our dividend to our divisor. Not 58 is bigger, but the 1. Who is bigger? Is the 1 bigger or is the 2 bigger? The 1 is bigger. That's why the 2 is bigger. 2 and 1. Who is bigger? My divisor is bigger because now I'm only comparing the one digit. That's how we know we're taking the 2 columns. So here, if the divisor is bigger, we take 2 columns because the divisor is bigger. Because the divisor is bigger, we can take 2 columns. We need 2 columns to be able to divide it out. So that's the question: is what times 2 is equal to 18? Because this is 18, 1 and 8. What times 2 is equal to 18 or less? 2 times 9. 2 times 9 is equal to 18. So I put 9 here and I take away 18. Take away 1, take away 8. That's how 2 is bigger than 58. It's not. It's the divisor. And it's the remaining divisor. That's why it's bigger. Can the abacus do division with repeating decimals? If yes, how to know if it's repeated? It can do remaining decimals. You just have to figure out when you want to stop. Just like in regular math, you just have to figure out when you're going to stop. Because I think there's like a rule in regular math to be like, okay, if I only have 3 decimals, I only need to divide it out to 3 decimals. So it is possible because you could do it on the abacus. But that's the thing is like, just like pi is infinite, you just have to figure out when to cut it off. What if I don't want to stop? Yeah, if you don't want to stop it, you can keep on going. But then you got to get a really big abacus, right? So this one is a 23 column. And there I lagged again. I think I lagged. So, and I think I just got to figure out a better way. I'm trying to figure out is I'm going to try to figure out how to stream from StreamYard. I was trying to figure that out and then I accidentally hit live. And then I was like, oh my God, I have to go live. So now I'm here. But I was trying to figure out is how do I go live on StreamYard? But that is division. So you can do division, forth. So it is very much possible. It's just, it's the same thing. It just gets complicated, and you just figure out like how to do another division. Let's do an easier division. Okay, you know what? Let's do this one. We'll do this one. 3 divided by 84. And you know what? Funny. This is what's going to be part of my adult introduction to abacus for adults. I'm going to make it. I'm going to make a book for introduction to adults. Introduction to abacus for adults. It will be an interesting venture, a journey. But yeah, I honestly didn't think adults would be interested in it. I just didn't think so. Anyways, it is stated 3 divided into 84. Yes, we're going to be 84 divided by 3. And the question is, what's my question? What's the first thing we need to do? Or is it 84 divided by 3? It is 84 divided by 3. So when we do it, it's 84, divide that by 3. That's what it'd be. Hey, lady, welcome back. So what we're going to do is we're going to figure out where our starting point is. Is 3 bigger than 8? No, 3 is not bigger than 8. How do I know? So what are we doing? what we're doing is the first thing we need to do is we need to find our starting point. Before we start going into figuring out what we're trying to do, we have to figure out where our starting point is. So if you notice there's two digits here, and then so there's two digits here, one digit here, so we're going to take it away. 2 minus 1 is equal to 1. So our starting point is 1. This is 1. This is my starting point. This is where I'm going to put my answer. As I put my answer, I'm going to put my dividend. I need to write it out. Dividend and divisor. So the question is now, who is bigger? Who is bigger, dividend or divisor? So this is why I put up the this. So who is bigger, the dividend or the divisor? The divisor is 3. The dividend is 8. If the dividend is bigger, it goes like that. Maybe I should do like this and then have a space, and we'll do that. So who is bigger, 8 or 3? 8 is bigger, yes. So what we're going to do is we're going to use column, and we're going to skip one column. So we're going to use one column. This is the one column we're going to take. This is where we're going to do, and we're going to skip this column, so we're over here. This is where we start moving. I don't know if Dandelion, you're still here. So the rule is if the dividend is bigger, I skip one column, and then I take one column. Why are you using E and S? Because I didn't want to write it out. E is dividend, and then the divisor. That's why. I can't say D and D because it doesn't make sense. I could say D and D, but it didn't make sense. In the beginning, I did do DS and DE, and I realized the D is the same. So I just made it down to the D and the E. Because we need to understand what we're trying to do. So when we have the dividend and then the divisor, it gets really complicated. I mean, in Abacus class, we call it the cat and the mouse, but that's another terminology. That's just part of my school. We call it cat and mouse. So the cat is the divisor. Yeah, right? Saying dividend sometimes made me stutter. Yeah, or lag. So, so in my classes, we call this as the cat, and then these are the mice. It's just a terminology that we use in our school, just so the kids can understand. But in regular math, when we do division, this is the dividend, and then this is the divisor. The reason why I use the D and the E is so we can keep track what we're trying to say, because it's such a tongue twister to say dividend and divisor. And sometimes I get mixed up, right? So we're back to here. We're gonna figure out how do you do 3 times what is equal to 8 or less. Why do we want to say 8 or less? Because we can't do more, right? We need to be able to minus. We need to be able to take away. So 3 times 2 is equal to 6, because you cannot take away 9 from 8, right? We cannot do 3 times 3. So because we have our 2, I'm going to put my answer here. There's my 2. Now I need to take away the 6. So remember, I'm only taking away the one column, so I take away 6. So now my dividend is still here. I still have leftovers dividend. I only want to look at the one column dividend. I'm only looking at this column, this dividend. So I have, who is bigger, 2 or 3? 2 or 3. My divisor, right? My dividend, my number 3 is bigger, right? The 3 is bigger. So if the 3 is bigger, this is my divisor. Yes, exactly. My S is bigger. If my S is bigger, this is where I do 2 columns. So I take these 2 columns. So now I know I am going to figure out how to multiply into these 2 columns. So sorry, I had a brain fart. No. Wait a minute. Did I do something wrong? Take away 6. Oh, okay. I got it. Sorry. So what's the problem here? The problem is it's too big. That doesn't make sense. Am I right? 24. Oh, sorry. Okay, I got a little confused. We're doing 3. 3 times what is equal to 24 or less? I got really mixed up, sorry. 3 times 4 is equal to 24 or less, right? So these are the two, because I was looking at the 2 and I was like, wait a minute, 2 times 2 is, anyways, so I got confused here. So 3 times what is equal to 24 or less? That's the question. That's the next question. Remember, we do 2 columns, but I'm going to put my finger here next to it. So what times 3 is equal to 24 or less? 3 times 8. So I have my 8, and I take away 20, and I take away 4. So my answer is 28. Yeah. So, yeah. So, I mean, we could do it long division. Not a problem. We could do long division. So this would be 2, right? 2 and then 6, and then this comes down to 24. But here in the abacus world, this is where we compare only the one digit. This digit and then this digit. Then we know we're doing 24, right? Because on the abacus, we don't see this. We don't see this. Abacus made math fun for me. Yeah. Yeah, abacus is like a little puzzle. Like, how do we do it? I like the fact that we can be like, well, if there is, how do we do it? So in here, the remainder is 24. You could see that we're doing it here, but on the abacus, you don't see what we're trying to do. Like this, that's why we only compare the one bead. So interesting how how it manifests, because we don't write it out. We just do it on the abacus. So we know that if 3 is bigger than 2, we're here. So we see, okay, 3 times what is equal to 24 or less? 3 times 8 is equal to 24. Did that make sense? So, yeah, I mean, it's interesting how everything fits together, but it does fit really nicely. If anybody has any questions, did that make sense, Amma? I don't know if we're all here, but that's the reason why I do the S and the E, so we can just keep track of what we're trying to say. Yeah, yeah, it's terminology really, but yeah, it's terminology. And we could do another one. But again, if you notice, we don't memorize our doubles. We don't memorize anything higher than 9. Okay, what are we gonna do? Oh, let's do this one. 7 divided by, no, 91 divided by 7. 91 divided by 7. So when we rewrite it, it could be 91, divide that by 7. So again, what is our starting point? We have 2 minus 1 is equal to 1. So what we're going to do, our 1 is over here. What we're going to do is we're going to put our dividend here. See, I got to think about it. I got to slowly think about it. So I'm going to put 91 here. Now the question is who is, and the divisor is 7. And I probably just lagged. So I'm going to label it ES. So when I look, there's my dividend, and here's my divisor. So my dividend is 9, right? My dividend is 9. My divisor is 7. So who is bigger? Who is bigger? My dividend or my divisor? Yes, Lady E. So my dividend is bigger. So when my dividend is bigger, this is one column. I will catch you later. See you later, Amma. So my dividend is, so I have to skip one column, and I have to do this column. So 7 times what is equal to 9 or less, right? 7 times 1. 7 times 1 is equal to 7. So I go here and I take away 7. So I take away my 7. So now I have my question. My dividend is 2. My dividend is 2. My divisor is 7. Yes, Lady E. So who is bigger, my divisor or my dividend? my divisor or my dividend is bigger? Exactly, 7. So my 7 is bigger. So then the question is 2, right? This is where it's 2 columns. So what do? 21 or less. 7 times what is equal to 21 or less? 7 times exactly 7 times 3. So I put 3 in my answer. So I put 3 here and I take away 21. I take away 2 and then take away 1. So then my answer is 13. Make sense? Easy, right? Easy, simple to use, easy to understand. What about division with decimals? We can. It's just the same. It depends on which side, right? So let me see if I can find a number. Do I see here? Nope. I think it's over here. Let me do this one. I'm just looking for decimals. It's been a while. I think I need to go somewhere else. The reason why I want to be careful with the decimals is the questions I have, we actually still have a zero. We have it zeroed out. We don't have any remainders. Is that true? Yeah. So a lot of the questions have to be prepared. So before I continue on, let me see if I can find one. Let's do this one. Oh, that's. Let's see. Still trying to find it. Let me see. Let me go here. Oh. Ooh. Okay. Let me see if I can. I'm trying to figure out a nice number. Okay. I think I got it. Okay. Okay. We have 6.6. Divide that by 58.08. Okay. Decimals in the dividend or the answer? You pick. Okay. So in school, we still need to multiply this out. So it looks like this, right? So if I rewrite the question, it's 66, divide that by 5800.8. This is going to be a little bit complicated. Oh, what did I walk into? Yeah. This is going to get a little complicated because now what we're doing is we're talking about 2 digits in our divisor. And this is another thing. This is when we're starting to get a little bit more complicated, right? We figure out our starting point. We have 2 over here and we have 3 over here. So 3 take away 2 is 1. We still have 1. But I got to use a different abacus. Am I going to use a different abacus? Yeah, I'm going to use my other one because there's not enough. Where is it? All right. Okay, I wasn't even here past 2-digit multiplication because I had class. This is complicated. This is a little bit more complicated, right? Now, I mean, this is what happens when we have, when people start to filter out. We can go into more complex in a higher math. So again, because we know this, it's easy, but there's like rules that we need to know. So, okay, where am I? I'm over here. I'm going to start, this is where my answer is going to be. So what I need to do is I need to put the dividend, I still need to label it, right? The dividend and the divisor. It gets a little complicated, but let's take it slow. So again, we're going to put in our dividends. 5, 8, 0, 8. Okay. Now, the question is who is bigger? It's still the same questions. We have our divisor and our dividend, right? Our divisor is 6 because we're only doing this. We're only doing the first bead, the first digit. We only look at the 6. We don't need to look at 2 of them. We just need to look at one of them. Who is bigger, the 6 or the 5? The 6 is bigger. So the question is 6 times what is equal to 58 or less? Notice I only talk about the 1 6. I'm not doing 6 and 6. I'm not doing 66. I'm only doing the 1 6. 6 times what is equal to 58 or less? I gotta think about it. 58. 9, right? 6 times 9 is equal to 50. Is it 4? 58 is 6 times 8 is 48. 9. 6 times 9 is 54. So I take away 50 and I take away 4. I take away 50, take away 5, and I take away 4. Right? Take away 4. I don't have any beads to take away 4. What do? I minus the 5 plus the 1. See how it's still adding and subtracting here. So now, whatever I do here, right, I got to do here. So this is a little bit low. This is the same question. 6 times 9, so it's 6 times 9 is equal to 54. So I got to take, I got to take away 54. This is the reason why this is a little bit, because now we got to do some more rules. Now we're getting more complicated. Because I don't have enough beads to take away 54. So, how did I get 9? Oh, because the 9's right here. 6 times 9, I have my answer here, 54. So I take away 50, I take away 4. Then I do it again, 6 times 9. Because I did this one and I got to do this one. Maybe this is not a better one. Let's do a different one. Because it gets complicated because the numbers are they're too similar. So let's try this one. 6.5, divide that by 33475. Maybe this is better because it's different numbers, right? So again, we're going to move it over here and move it over here. We still need to do that. I'm going to start with a new question because same numbers are confusing and I apologize for that. So we're going to redo this. So we have 2 digits here and 1, 2, 3, 4. 4 digits here. So 2, 4, take away 2 is 2. So our starting point is at 2, 1, 2. I'm going to put my dividends on the abacus. So I do 3, 3, 4, 7, 5. Okay? 3, 3, 4, 7, 5. So my dividend is still here. My divisor is here. So who is bigger? The divisor is 6, or my dividend, which is 3. You only do the 1 digit, so the 3. So my 6 is bigger. So my 6 is bigger, so it's 6 times what is equal to 33 or less. 6 times 5. So 6 times 5 is 30. That's the closest. So I'm going to put 5 here. I'm going to take away 30. Take away 3. Take away 0. All right. This is where it got confusing really quick because it's a double digit. So whatever I do here, right? Whatever I do here, I got to times this one. So now what do? I do 5 times 5 is equal to 25. So now I got to take away the 5, take away the 25. Why do I do this? Because I already have my answer. So because it's double digit, I have to go back, and if I do something on the 6, I have to do the same thing on the 5. So we have it, right? 6 times 5 is 30, and then 5 times 5 is 30. Where did I get the 5? I got the 5 here. My 5 is the answer from here, right? This is the same 5. So I'm going to take away 25. I take away 2 and I take away 5. Minus the 10 plus the 5. Okay, so now what? Now I got to compare again. Who is bigger, my dividend or my divisor? Yeah, it gets complicated really quick. It gets complicated, but this is why you have to build to it, right? Don't forget, I've been teaching this for 20 plus years. You've only been learning this like just recently. So you have to be careful. I mean, we can do it. We can continue on. But it is taking a little bit. Like it's a little bit more complicated. But there's rules that needs to happen. So now, who is bigger? My dividend, which is 9, or my divisor, which is 6. Again, I'm only talking about the first digit. I'm not doing the whole number. I'm only talking about the first digit. So when we break it down, we only talk about the one digit to know what we're trying to do. Yeah. So my 6, no. My dividend is 9. So no, it's not the S. It's not 6. It's the 9. So now it's like this. What are we doing? Well, now we got to figure out if my dividend is bigger, it's only one column. So I go over here, I take this one column, I skip one column, and I'm only going to use this one column. So now the question is, what times 6 is equal to 9 or less? 6 times 1 is equal to 6. So I add my 1 here. I add my answer here. I'm going to take away the 6. I don't know where I lagged, but I'm letting you know. I'm taking away the 6. So I have my 9 and I take away the 6. Okay, fine. Here is the thing. Whatever I do with the 6, I got to do the same thing with the 5. So now 5 times 1 is equal to 5. 5 is a single digit. Because 5 is a single digit, you have to go back one column. I'm laughing because it just got complicated really quick. So, because it's 5 times 1, don't blink. 5 times 1 is 5. 5 is a single digit. I go back one column, right? Because it's a single digit, I got to go back. So pretend that it's a leading 0 with a 0, 5. So there's a 0 and then there's a 5. Maybe that will help. So I'm going to take away the 5. So I take away my 5. Blame Ethan. He wanted decimals. Okay. So I still have dividends. Notice I still have dividends. You have to keep track. I still have dividends. What do? This is my dividend, 3. My divisor is 6. Who is bigger? My dividend is still bigger. My divisor is bigger. So I got 2 columns. So it's like this, right? So it's 2 columns. What times 6 is equal to 32 or less? 6 times 5 is equal to 30. We're back to here. So I add my 5. So now we're in the decimals, right? Because it's my between here. So I have my 5 and I take away 30. Whatever I do to the 6, I got to do to the... Whatever I do to the 6, I got to do to the 5. So 5 times 5 is equal to 25. So I take away 2 and I take away 5. So now my answer is 51.5. 51.5. So there it is. 51.5. Yep. That's how we do decimals. It's the same thing. It's just now there's decimals. That's all it is. But the reason why this got complicated because now I have 2 digits that I have to worry about. When I have 2 digits to worry about, I mean, obviously it gets more, right? You can do 3 divided by 3 digits, 4 digits, and then this gets huge. So division on the abacus gets a little bit more complicated because we have to remember our formulas. So repeat the same thing on the 5. Yes, exactly. So whatever you do on the 6, you got to do to the 5. So if we do 6 times 5, then it's 5 times 5. If it's 6 times 1, then it's 5 times 1. And then it's again 6 times 5 and 5 times 1. So whatever you do on the 6, you have to multiply it to the 5. That's how we do it in Abacus. Exactly. Exactly. Whew, that was a little bit. I do blame Ethan. But I mean, that's why I'm very careful depending on like actually it's easier on Abacus than I thought. It is easier if you when you start seeing the pattern and also the when you see the rules. When you see the rules, it makes a lot of sense. But I have to explain the rules, right? I have to tell you what the rules are before I continue on. So there's more to it, right? There's more rules. There's more rules in division than everywhere else because you just got to keep track of everything. But yeah, I do find multiplication and division easier on the abacus because we move and we can see the things. We can see our products and stuff. But notice like when we do this, right? When we did some of this is they called it partial quotient. Abacus we just call it division. We don't do a lot of math terminologies in abacus, and so again, as I said before, that's why I'm here. I'm trying to make it easier. I mean, it's really easy, but see that it's one thing to see it, right? It's one thing to see the video. It's one thing to go live. It's one thing. It's another thing to talk about it in a book and in written form. And that's my goal. My goal is to make this in written form and it'll be easy to see. So just as I did my adding and subtracting, I'm going to do the same thing with multiplying and dividing. But, you know, again, this is a whole series that I'm thinking about. And it just takes time to like figure out how to analyze, how to make it simple enough to understand. Because there's a lot of I was reading the text and I'm like, oh my God, I just got lost. But again, whatever, I mean, but that's why I enjoy our TikTok lives because I can have conversations. And as I have conversations, I could see where people get tripped up on. But yeah, exactly. So I think what I'm going to do is I'm going to have this chart in my workbook so then we can write out like, because when you see this, it's a lot easier to understand, right? And before, we didn't do this. I was just taught to do this and then we would just talk about it. What about multiplications with decimals? Okay, Ethan, you're very ambitious today. Very ambitious. You're very lucky there's only maybe four of us. Okay, if you guys are okay with it, we're going to do multiplication. Okay. This one will be an easy one. Easy peasy. Lemon squeezy. All right, I'm going to pick another color. Anyways, okay, this one. I don't know what color this is. Anyways, so let's do this one. Easy for all. I'm just curious what Abacus can do. The only thing Abacus can do really, adding, subtracting, multiplying, dividing, and you could do it by the decimals. That's all we can do. Somebody asked me if I could do algebra. No, I can't do algebra. That's it. You don't do algebra on Abacus because algebra has like letters and numbers and so forth. So what Abacus does is it provides a groundwork and how to think critically and analyze the framework. So Abacus provides a beginning part, a stepping stone, but Abacus is not the end all. Easy for all. Yes, Lady E. Easy for all. Simple to use, easy to understand. So here is my multiplication question. 5.47 times that by 44.2. It's the same thing. We actually don't need to worry about the division, the decimals behind when we start counting our numbers. We need to just worry about our whole numbers. So 1 plus 1 is equal to 2. So our starting point will be 2. Does that make sense? 1 plus 1 is 2. So I don't have enough beads. Maybe I'll do here. Okay, we'll do here. Right? So if I start here, 1 and then 2. It's the same thing. I'm telling you. What are we doing? Okay, well, this is 2, right? What do we do? 4 times 5 is 20. So I have my 2 and my 0. I had 2 and I put my 0. 4 times 4 is 16. I add my 1, and then I add my 6. 4 times 7 is 24, right? 4 times 7, is 24. Is that right? No, 28. Sorry, 28. I add my 2, and I add my 8. Okay, I'm done with this. So remember, I started at 2. Now, because I'm done here, I got to go to 1 because I only have 1 left, right? So now I'm going to change a different color. I'm going to start here at the 1 because now I have to reassess. 0, because this is my decimal. This is 0 and then my 1. So I start here. So now I go 2 times 5 is equal to 10. 2 times 4 is 8. 8 is a single digit. So I'm here. I have to go back 1 column because it's a single digit. If you want to think about it, it looks like this, right? If we made it double digit. How do we add 8? Plus the 10 minus the 2. I'm still here. My finger is still here. 2 times 7 is equal to 14. So I add my 1, and then I add my 4. And that's it. That's my answer. 22 point, right? You need to have the point here. 22.974. So that's the answer. 22.974. Is that right? Yeah, that's it. Right? Because we have to make sure that when we multiply out, that's how we do it with our decimals. Yeah. Oh, basically it's normal multiplication, but longer with the decimal point. Yes, exactly. Exactly. You know, and the one thing is making sure and you keep track of your columns. When you keep track of your columns, everything is easy. Everything is easy. That's why it's easy to go. It's easy to go to decimals. I mean, we don't do fractions. You have to multiply that out, right? But that's what fractions are. Fractions is multiplying or dividing it out. But yeah, that's what it is. Basically, division with a decimal is just moving the decimals over. Okay. Anybody have any questions? This is like a little mastermind class, like really, really, really mastermindful. Anybody have any questions? Yeah. Thank you so much for the hearts. Whew, almost at 3,000 likes. Okay. If that made sense, I mean, if there's anything else, but that's what my plan is, to actually make a workbook for adults. You know, because I'm thinking like, you know, it's okay, you know, if the adults want to teach their child. I didn't, honestly, to tell you the truth, I didn't teach my kids. I took it to the school and I had another teacher teach my kids, because teaching your own kids is another thing altogether. And it was really hard because Abacus at the time wasn't very fun. So it was like, oh, okay, you know, it'd be better if my kids learned it from somebody else. But yeah, Abacus is Kalki? I don't know what that means. What is Kalki? Kalki? Abacus is Kalki? Abacus was really boring. So when my kids were doing it, it was just a bunch of questions. That's what it was. Since I learned the abacus, I want to be an abacus teacher. Oh, great! I'm so happy. You just got to find students. A lot of the parents, what I noticed, a lot of parents are interested. Some parents are like, oh my God, I want my kids to do abacus competition. You could, but that's not one of my focus. But kids are. Ethan. You know, I really enjoy talking to children because I can really be funny with them. And I enjoy being funny, and try to make them laugh and try to make them feel comfortable. But, you know, again, I'm not their buddy, I'm their teacher, but I, try to add some sense of humor to them. I do like it because I like seeing when they start making the connections. I like seeing the just like how you guys are making connections, right? It's really addicting to see when people make connections, and not too many adults are. I gotta figure out this lagging thing. Um, let's see. Let's see. Here's my settings. I can't figure out is what I want to be able to. I need to be able to figure out how to put this into StreamYard. That's what I want to do. I'm going to put it into StreamYard, but I haven't figured it out yet. So going back to this, so Abacus, if you, I mean, if you really want to be a Abacus teacher, you might want to start teaching senior citizens. Those people that are, they don't have a lot to do, but it keeps their mind active. So it'd be like have them do like Sudoku or word problems, or not word problems, word searches or crossword puzzles. Abacus would probably be doing the same. Yeah, that was one of my goal, is to go further into doing this to like all stages of life. And I think it's just nice to be able to be number flexible but also keep your mind active. So I think my mind's pretty active because I have, like, in my head I have like a set of checklist, right? I have a checklist of what I'm trying to do and what I want to do. And so I think that kind of helps build a structure, but still knowing how to maneuver the questions and stuff. So yeah, it gets really hairy when you do division because it always depends on the numbers, because the numbers being done is always different. So usually when I talk about it in the very beginning, I usually stick around with like adding and subtracting and doing the more simple division questions, as you've seen, right? So like 87 divided by 3. We can do 87 divided by 3. That's easy, right? Because that's the right, and it's the same thing. So what we do is, it's interesting. The other thing is, after the kids know they're adding and subtracting, they know their multiplication, like they know the multiplication facts, then they start going into actually doing dividing and multiplication right away. We don't wait till 5th grade. We just go right after the other. So there's a whole curriculum behind this. So again, here is our starting point. Our starting point is 1. How do I know? Because I have 2 here, 1 here. So 2 minus 1 is equal to 1. So what I'm going to do is I'm going to put my dividends, right? I got to write it out. Dividends and divisor. So again, I don't know. I didn't do this one. So I'm going to put my dividends here. So I put 80 and I put 7. So then the question is who is bigger, dividend or divisor? If my dividend is 3, no, my divisor is 3, my dividend is 8, right? Then my dividend is bigger. My dividend is bigger. So I'm going to take one column because because my dividend is bigger, I only do one column. So I do one column, I take one column, and I skip a column. So now my question is what times 3 is equal to 8 or less? 3 times 2 is equal to 6. So I put my answer here. I put 2 here, and I take away 6. So I go to 8 and I take away the 6. Now, who is bigger? My dividend, which is 2, not 27. I only look at the one column, 2. And then my other one, my divisor is 3. My divisor is bigger, so I know I'm going to take these 2 columns. So what times 3 is equal to 27 or less? 27 or less. 3 times 9. 9. Take away 20, take away 7. And that was easy, right? So my answer is 29. Yeah. What about 14 divided by 6? Same thing, because you got to still multiply it out. So we have 6, 14. We still need to move our decimal. So we have this to here. So it's actually 6 104. That's it. So let's work it out. 3 take away 1 is 2. 1, 2. So I'm going to put my answer here. 1 and 4. Who is bigger, cat or mouse? Who is bigger, dividend or divisor? Dividend, divisor is 6. Dividend is 1. My divisor is bigger. So if my divisor is bigger, it's taking 2 columns. 6 times what is equal to 14 or less? 2, right? 6 times 2 is equal to 12. So I add my 2 here, and I take away 12. Take away 1, take away 2. So now this is a repeating number. We're gonna get a remainder, because who's bigger, dividend or the divisor? My dividend is 2. My divisor is 6. Again, my divisor is bigger. So what times 6 is equal to 20 or less? 6 times 3. I add my 3 here and I take away 20. I take away 18, right? 6 times 3 is equal to 18. So I take away 1 and I take away 8. And again, so now it's repeating. This is where I put the remainder. So it would be, the way it looks, it'd be 2, 3, 2, 3 with the remainder of 2. That's what the answer is. Would I put in decimals? You could do it, but then it's just repeating, so it doesn't matter. So, anybody else have questions? Anybody have any questions? We can do more abacus. But actually, you know what? I'm going to go for breakfast. I haven't eaten yet. And then I got to figure out I have to find out where my RTMP is. I don't even know where that is on the TikTok thing. All right. If anybody has any more questions, I mean, I'm gonna sign off. I'm gonna sign off because I'm gonna have some breakfast. It's still 10:30 for me. Let me know. I'll see you guys in the next live. Any burning questions? Have a good breakfast. Please don't choke. I will promise not to choke. Yeah. But before I leave, was there anybody have any dying questions, any burning questions that they want to, any abacus burning questions? Let me paraphrase that. Oh, you know what, Ethan, go to sleep already. Go to sleep already. This can wait. Yeah, I'm on live. I'm on live as many times as I can, but I got to figure out this. Lagging problem. That's the problem. All right. Thank you everybody for joining. Thank you everybody for attending. Thank you so much for the conversation. I do enjoy it. Again, I do enjoy our conversations. Thank you so much. Have a good day. Have a good night, Ethan. Go to sleep already. Go to sleep. Go to sleep. Okay, bye. End live.